The Aldol reaction is an important reaction in organic synthesis because it allows the reaction of an enolate with an aldehyde or a ketone to give beta-hydroxycarbonyl compound. Now, the beta-hydroxycarbonyl compound can undergo elimination reaction to give the corresponding alpha-beta unsaturated carbonyl compound. So thus, it's a very useful reaction in organic synthesis. Traditionally, the Aldol reaction involves reaction of acetaldehyde. So if acetaldehyde is treated with catalytic base, it should give the corresponding alpha-beta unsaturated carbonyl compound, preceded initially by the beta-hydroxycarbonyl compound. This is called carbonyl condensation reaction, where two carbonyl units, if you like, are condensed together. So basically, two carbonyl units or units of the same carbonyl compound, such as an aldehyde, for example, or a ketone. Obviously, an important requirement is the presence of an alpha hydrogen or a hydrogen at the alpha position, obviously, that is acidic. Let's draw the classical, if you like, or the traditional Aldol reaction that involves reaction of acetaldehyde with catalytic base. So acetaldehyde with catalytic amount of, let's say, sodium ethoxide. Of course, an alkoxide or the hydroxide ion would not be thought of initially as a base to deprotonate carbonyl compounds at the alpha position. That's due to the base strength. Obviously, carbonyl aldehydes have pK at the alpha position of about 17 or 18, something like that. Ketone about 20, if you recall. Esters 25. Alkoxides, of course, come from alcohols, or alkoxide come from alcohols whose pK is about 16. So therefore, the alkoxide is not strong enough as a base to deprotonate carbonyl compounds at the alpha position. But under catalytic conditions, a catalytic amount or a small amount of an alkoxide should convert the aldehyde into a small amount, only of course a small amount of the aldehyde to a small amount of an enolate. Let's draw the structure of the enolate that should be obtained. That's an enolate of acetaldehyde upon treatment of acetaldehyde with catalytic amount of sodium ethoxide. Assuming, for example, you have 0.01 mole of sodium ethoxide and 1 mole of acetaldehyde. So 0.01 mole of the ethoxide base should convert 0.01 mole of the aldehyde to give 0.01 mole of the corresponding enolate. So again, this is the enolate. And of course, enolates are nucleophilic, so they should react with electrophiles. If there is 0.01 mole of the enolate, there should be 0.99 mole left or unreacted of acetaldehyde. So 0.01 mole of the enolate should react with 0.01 mole of acetaldehyde in nucleophilic addition reaction. So the enolate should actually attack an amount of acetaldehyde. If there is 0.01 mole of the enolate, it should react with 0.01 mole of an unreacted acetaldehyde. This reaction, again, as you recall, is called nucleophilic addition. So the Aldol reaction is specifically a nucleophilic addition reaction where an enolate reacts with an aldehyde or a ketone. Let's write the product that's obtained so far. So this is the product that's obtained as a result of the attack of an enolate on an aldehyde or or acetaldehyde in this case. It is beta alkoxy aldehyde. So this is the alpha position, obviously, coming from the enolate. And of course, this unit comes from acetaldehyde. This unit comes from the enolate. And of course, this itself comes from the same source, which is acetaldehyde. This beta alkoxy carbonyl compound can undergo protonation to give beta hydroxy carbonyl compound, which is this one. So this is beta hydroxycarbonyl compound, or beta hydroxyaldehyde specifically in this case. Now that's as a result of protonation of the beta alkoxy aldehyde. If you look at the structure, it is actually an aldehyde, and it has a hydroxyl group at the beta position. So it is an aldehyde and an alcohol at the same time. It is an aldehyde here, and thus it's ald, the name ald. So this ald is due to the presence of the aldehyde function group. It is also all because this unit is an alcohol. So that's exactly why it's called the Aldol reaction, because classically or traditionally the aldol product contains an aldehyde and alcohol. It's a condensation reaction of acetaldehyde itself. When acetaldehyde is treated with catalytic amount of a base, the catalytic amount of the base should produce a small amount of an enolate, which then initiates the Aldol reaction, or that small amount of the enolate then reacts with a similar amount of the unreacted acetaldehyde in nucleophilic addition reaction. The initial product is beta alkoxy aldehyde, which is then protonated in a subsequent step to get beta hydroxycarbonyl compound. So this is the Aldol reaction. It's a reaction between an enolate and aldehyde or a ketone to give beta hydroxycarbonyl compound in general.